advanced algebra, we're going to look at the graphs of logarithms. Now our goal here is really to get an idea of the basic behavior of our logarithmic functions so we can kind of have this beginning understanding of how logarithms will change with values. Now the key for this is our logarithmic functions are inverses. They're inverses of our exponential functions. What that really means is that our x and y values are interchanged. So when we look at a logarithmic function to graph it, we really need to look at an exponential. So if I look at an exponential of y equals 3 to the x, so for my chart here, if I do 3 to the negative 2, I have a 1/9. 3 to the negative 1 is a 1/3. 3 to the 0 is 1. 3 to the 1 is 3. And 3 squared is 9. So a logarithmic function that is really similar would be this right here, where we have y equals log base 3 of x. So that 3 that looks like it's a little bit smaller and lower, that's a base. Similar here, that this 3 here in the exponential, we call that a base too. So both of these are called bases. If I was to switch this logarithm here into exponential form, that's where I would get this. Okay. And in here, we see that how we can interchange them throughout. I'm using just A, B, and C in those cases so I can kind of follow where they go. So like when I see the B as the base here, that's at the bottom of the exponent. Okay. When I see this A here, so I'm taking the log of that A, that would be the value on the other side of that base. And this C right here, that's the exponent. So logs really equal an exponent. So if I'm graphing and I start with the circle here, y equals log base 3 of x, I would want to change it to logarithmic form. So I'm thinking here my base is 3, my power is going to be what the log equals. So my power is the y. And now this exponential will equal x. So if I was trying to find out values for this y, 3 to the y equals x, I would really want to plug numbers in for the exponent, for the y value. So if you see my table here, I've changed, and now my y has the negative 2, the negative 1, the 0, the 1, and the 2. So if I put negative 2 in for the y, I find out I have 1. I'm going to do this in different color here for that one. Okay, I would have 1/9 for my x. If I put negative 1 in for y, I have 1/3 for my x. If I put 0 in for y, I have 1 for x. And as I continue, I'll have 3 for x for the next one and 9 for the last one. So my x and y switch around. So here, these are now the opposite from here. They switched around. Okay. This y column was the x column for the exponential. So if I compare these two graphs, I'm going to graph the exponential in red. So if I do my points here, it's going to look like this. So this is my exponential. I do my logarithmic in green. So x just is 1/9 and my y is negative 2. X is 1/3, my y is negative 1, 1, 0, 3, 1, and 9, 2. It's going to look like this. My logarithmic. Okay. So they have similarities to them. They actually both have asymptotes. My logarithmic asymptote is going to be vertical here. So this is my asymptote for my logarithm. this case will be x equals 0. And then I have 2 points that are really, really key. It'll be these 2 points right here. So this point right here and this point right here. So when x is 1, y is 0. And when x equals the base, y is 1. This grows really slowly. Also, if you look for your domain, we don't have any negative x values. Our x values are always positive. So our domain for this is x is greater than 0. And our range for this, our range, I'm ahead of myself here, is all real numbers. My range is going to be all real numbers. So it goes down forever and it goes up forever. Even though this is going really slowly up, it's going to go up forever. What this really tells us, since our domain is x is greater than 0, I can only take the log of numbers that are more than 0. It's impossible to take the log of 0, and it's impossible to take the log of any negative number. So that's the basic part of this. We see that it doesn't grow that fast, and so if we were taking the log of a really high number, we're probably going to get a lower number as an answer. So this is one reason why we use logarithm to use a scale for something, because especially when we're trying to describe really large numbers, we can use the log, or really small numbers, we can use a logarithmic scale to be able to identify that. So for instance, like Richter scales, that is a logarithmic relationship, because if we really looked at those intensity levels, those numbers would be really huge. But instead, if we're talking about like a 6.5 Richter scale reading on an earthquake versus an 8.2, those are easier numbers to talk with. So that's where we see that happen in real life. So our graph just gives us that visual of what's going on.